Now let's start this chapter off with basic table of trigonometric ratios. Now, basically, what this means is that mathematics have constructed tables given the values of the trigonometric ratios of large number of angles between 0 and 90 degrees, and these are called the tables of natural sines, cosines, and tangents. So these are the basic trigonometric functions we deal with, and we can construct the other ones by using them. Technically, you can construct the table of a tan function as well from both the sine theta and the cos theta. So basically, technically speaking, the sine theta and cos theta tables are the most important ones because the others build off of them. Now, the reason we have three is because these are angles of triangles, basically, right? That's why they're between 0 and 90 degrees. So basically, if you have, let's say, this triangle over here, right? A right angle triangle, and say this is theta. Now, let's say that theta is 0 degrees, and you know that sine theta is basically, let's define these sides. This is the opposite side, this is the hypotenuse, and this is the adjacent side. Okay, so sine theta is basically this angle. If you have to take the sine of this angle, it has to be opposite over hypotenuse, right? So if the angle is 0, obviously there will be no opposite side, which is why sine theta is 0. On the other hand, cos theta is 1, because if this angle is 0 degrees, means this entire thing is closed down. That means that the adjacent side is equal to the hypotenuse, right? They will intersect. So cos theta will be 1, and tan theta is basically the adjacent over the opposite over the adjacent. And since the opposite side is gone when the theta is 0, that means that tan theta will be equal to 0. Now, sine 30. Let's talk about sine 45 first. Sine 45 means that you have basically a equilateral triangle. So basically, say that this is your 90-degree angle, then these other two sides must be equal in length, right? So this will be 45. If this side is 45, this side will also be equal to 45 degrees, because the total angle inside the triangle must eventually equal to 180 degrees. So we already know that 90 plus 45 plus, we know the two angles, 90 and 45. So the third angle must be 45 for all of this to equal 180 degrees. So this is an equilateral triangle since two angles are the same. And the adjacent in this case will equal the opposite side, right? Because the angles are equal. So this side and this side are equal, and so you're just left with the hypotenuse. And let's say that these sides are, if the adjacent is 1, right? Yeah, so if the adjacent is 1 and the opposite is also 1, the hypotenuse can be found by the Pythagoras theorem, which states that the adjacent square plus the opposite square must equal the hypotenuse, right? So the hypotenuse square, sorry. So the hypotenuse is basically equal to 1 plus 1 under root. So under root 1, right? So yeah, under root 2, because it's 1 plus 1, so 2 and under root 2. And yeah, so basically this would give you, since it's the opposite over the hypotenuse, that would be 1 over under root 2, and that's exactly what you have here. So all of these values that you see over here, they can be found by the basic triangle, right? And just to make life easier for you, for yourself, if you're given the values of sine theta and cos theta, you can find tan theta by just taking sine theta over cos theta, right? You already know this. Tan theta is equal to sine theta over cos theta, which is why in case of 90 degrees, sine theta is 1, but cos theta is 0, which means that this cos theta in the denominator will become 0, and hence tan theta will become undefined. right? So yeah, this is just a table. It's easy to derive all of this, but again, if you want to memorize it, that's for your benefit as well.